All right, let's do this exam real quick. I'm not going to use Dr. Racket for parenthesis completion. So if I skip one, just deal with it, I guess. This is so small, I can't even read it. Okay. Nailed it. All right, what are we supposed to do? Extract the 6. So we're supposed to get this guy. So we're going to do the coulter. The coulter of it. The coulter of it gives us this guy. I'm just going to start with that. CD. That gets us, and then the car of that gets us that list, CADDDR. So now I'm looking at that guy. So then I want the CADDR of that. That'll give me that list. And then the CADR, the coulter, and the car of that guy, and the car of that guy. So the coulter of that gives me the list containing the 6. The car of that gives me the list 6. The car of that gives me the 6. And here we'll just assume that guy's called list. So coulter, car of that guy. Yeah, I think that gives me the 6. Okay. Question 2, write a function, name list of divisors that takes a number as a parameter and returns a list containing all of the numbers that evenly divide that number. If the input was 9, your function should return 1, 3, and 9. So we can assume that there is a function called mod that takes 2 parameters and returns the remainder of integer division. Okay. List contain all the numbers that evenly divide it. Okay. What did I say to call it? List of divisors. Spell that right? I don't know anymore. It's going to suck without the. So that's going to be a lambda. It's going to take in a num. We'll do a cond. Equals num 1. So we're going to count down to 1 so we can boil down to the list containing a 1 if it's equal to 1. Otherwise, if this guy's supposed to take in 2 parameters, right? What order I say to do it in? 1, 3, 9, that's fine. This guy called helper. So this would be a lambda. I'm going to take in a and a B, something like that. I want this guy to go through all the numbers between 1 and equals a B. Then we'll just boil down to the list containing B, else if mod B A equal to 0. There. I'm going to call this guy orignum, and we'll call this guy kernum. It'll be easier for you to follow. Orignum. So in our example here, orignum would be like 9. Kernum will be 1, 2, 3, 4, all the way up to 9. So if kernum is equal to orignum, then just boil down to the list containing orignum. So if orignum was 9, I'm just going to boil down to the list that's 9. Otherwise, if the current value evenly divides, I'll cons kernum onto whatever helper returns kernum plus 1 and orignum. That's what I do. Let's see. So this is this closes the helper, this closes the cons. Otherwise, just call the helper. So then actually what I can do down here is I can just boil down to helper of I'm lost. I've been driving too long today to be doing this. We'll do it anyways. Okay, so helper passing it my kernum, which is going to be 1, and my orignum, which is whatever num is. So this will call helper, passing it originally a 1, and my all the way up to whatever num was. So in this case, if I passed it in a 9 for num, this will call it 1 and 9 here. This will go all through the numbers between 1 and 9 inclusive. When it finally equals to 9, I'll just boil down to the list that is that orignum, the list that's 9. That'll finish off my cons. Otherwise, I'll ask if the current value is evenly divisible. I'll cons the current number onto whatever helper returns on the next number. Otherwise, just call helper on the next number. Might be a parenthesis off here or there, but I think that's pretty close. Does that get me those guys? I think so. Write a procedure called FizzBuzz that takes a number as a parameter, returns FizzBuzz if that number is evenly divisible by 3 and 5, Fizz if it's evenly divisible by 3, Buzz if it's evenly divisible by 5, and the number itself otherwise. Okay, so define FizzBuzz. It's going to be a lambda that takes in a num. And this guy is going to have a bunch of cons if it's divisible by 3 and 5. Cond and mod num3 equal to 0 equal mod num5 0 and the FizzBuzz. For these, that's that. It's got to be at least pretty close. Num mod 3 is equal to 0. Num mod 5 is equal to 0. And those together, if that's true, FizzBuzz. Equals mod num3 0. Is that one just Fizz? It's evenly divisible by 3. Buzz is only by 5. And a final else boil down to just the number. That should end the cond, the lambda, the define. All right, so something along those lines takes a num as a parameter. If it's evenly divisible by 3 and 5, boil down to FizzBuzz. If it's only evenly divisible by 3, Fizz. Only evenly divisible by 5, Buzz. Otherwise, boil down to just num. Write a lambda calculus expression where a variable x occurs free and a variable y occurs both free and bound. All right, so let's get a x that occurs free. X occurs free and a variable y occurs free and bound. Something like that. So this would be an app expression. So in this case, y occurs free. In this case, y occurs bound, because this lambda is our app expression where this is the function, this is the parameter being passed in. So this y is not bound by anything here. This y is bound by this definition. This x occurs free. So this x occurs free, this y occurs bound, this y occurs free. That's what we're supposed to do. X occurs free and a variable y occurs both free and bound. Okay. 1321 from base 8 to base 16. Could I do math? All right. So we're going to go octal to binary and binary to hex. 1321. 13 to 1. So this is going to be, so for octal to binary, it's 3 bits, 0, 0, 1. 0, 1, 1, 0, 1, 0, 0, 0, 1. So that's the binary version of that guy. Now we break it into 4-bit chunks. So this is a 0, this is a 2, this is a 8, 12, 13. And this is a 1. 13 is A, B, C, D. So this is a 2D1. Is the answer to this one. So I went from octal to binary, which was in 3-bit chunks, then spread those back into 4-bit chunks, then went back to hex. So I used the trick. What is the grammar? What is a production? Grammar is a description of a language. A production is an individual rule in a grammar. Something along those lines. All right, bin tree looks like this. It's either an int or it's a symbol followed by 2 binary trees. Okay, so we need a one that has 5 numbers in it. So that means we're going to have 5 leaves because a binary tree is a symbol with 2 a left and right binary tree with our leaves being an int. So I'm just going to write some trees here. It's 2 numbers. That's 4 numbers. So here's a binary tree with a left and a right child. Left tree is this guy. Right tree is this guy. We'll say D5 like that. So this is a binary tree. Symbol, left child, right child's a leaf. This is a binary tree, left child, right child, where the left child is an A with a 1, 2 as leaves, and the right child is a B with a 3, 4 as leaves. I think that'll do it. Keeping in mind here that these are 2 different forms based on the last question, what's a grammar? This whole thing's a grammar. We have 2 productions. It's either an int or it's a list containing a symbol followed by a binary tree, followed by a binary tree. Write a procedure called sum tree that takes a bin tree as a parameter, returns the sum of all the numbers in the tree. Okie dokie. Lambda, that'll take a tree as a parameter. Now I'm probably going to need a helper here to pass around my sum. So I'll just say define helper lambda that takes in a tree and a current sum. And I'll go ahead and call my helper, passing it a tree and an initial sum of 0. So really my work here is going to be inside of the helper. So the only time I'm actually going to have anything to sum is when I have a if number tree plus some tree. So if I'm looking at a number for my tree plus some tree, otherwise I must be looking at the other production, in which case I'll add helper, the car of the cooter of my tree, and the car of the cooter of my tree. Well, sorry. Helper on that. Helper on that. Okay. Why did I say car of the cooter and car of the cooter? If I'm looking at that second production, car of the cooter is that guy. Car of the cooter is this guy. How do I get the sum of this binary tree? I call my helper on this binary tree, passing it. I need to pass it my current sum. It takes 2 parameters. And I'll add those 2 things together. Actually, you know what? I don't want to add the 2 things together like that. I want to say that. And then I want to add sum to that. That way I'll treat each individual subtree as its own little sum thing. And I'll just say whatever my current sum is, added to the things that have come out of those. And actually that's redundant. I didn't even need to pass it a 0 then. I'm just presuming everything starts with a 0. It's still going to work. I'm just adding 0 to, I'm saying 0 plus. I'm never actually changing the value of sum here. I'm always just passing in a 0. So I could have actually just done this inside of call that guy sum tree. Looking at a number, just boil down to tree. Otherwise, add the 2 helpers together. I wasn't using the 0 base before. Pass it the whole tree. If I'm looking at just the number for whatever tree I'm looking at, it boils down to its value. Otherwise, add helper for the left tree and helper for the right tree. But it's not helper anymore. Now I called it sum tree. Okay, I think that'll do it. What would the purpose of storing lambda expressions in our environment be? Allow us to store functions as variables in our language and to inputs using our call function or call expression, whatever. Last, write a procedure called apply GD that takes a list of positive numbers as a parameter and returns a new list of the same length with every number replaced by the largest integer that evenly divides it. So I need to find the largest integer that evenly divides it, probably assuming it's not the integer itself. Okay. Say define largest num lambda. It's going to take a num in as a parameter. I'm going to define helper to be a lambda that's going to take in a curval and that num. So we'll start at num minus one. So for instance, if we're looking for the largest value that even divides, for instance, 9, I'll start checking 8, then 7, then 6, then 5, so on and so forth. I think I had somebody ask when they were taking the exam if technically the number is just itself. It's a pretty shady way of reading the question, but technically I can't fault the logic that the largest value that even divides 9 is 9. But I'm going to write it the way I intended it. So if equals curval 1, just boil down to 1. I'll write this as a cond. Right. If equal mod num curval 0, boil down to curval. Actually, I didn't even need to do this one thing. This guy would actually suffice, because 1 would evenly divide it. It's redundant. I could have just done this if else. I'll helper on minus curval 1 and num. That'll end the cond and end the lambda and the helper. This guy will boil down to, we could take in the curvals. So this is, I'll call helper on minus num1 and num. So that's what largest num does. So largest num takes in a number and boils down to the largest value that's less than that number that evenly divides it, using this helper as a helper. And I'm supposed to call it, right, apply GD that takes in a list of positive numbers. Lambda, it's going to take in a list. And what is this supposed to do? Probably should have read that first. List of positive numbers as a parameter returns a new list of the same length with every number replaced by the largest integer value that evenly divides it. Map. So we will map largest num across list. Largest num takes a single parameter num and boils down to the largest number less than num that evenly divides it. So I'm going to map that function across each element of list. So that's apply GD. If you didn't want to use map, you could have done our pattern where we go through, and here, I'll even write it. Apply GD2. The lambda that takes in a list as a parameter. If no question mark like that list, then boil down to, well, you can boil down to the empty list or just a list. Otherwise, we will cons largest num of car list onto apply GD2. or list. And that'll do it too. All right, I think that there might be a parenthesis off here and there in that, but I think that all should be pretty close to the logic. Like I said, when you took it, I expected that you didn't use your interpreter. So if you have a parenthesis off, it's not the end of the world. So I don't know, it might be fun for you to go and test my code to see how well it works after hours of driving, but I wanted to make sure you had this. So anyways, that's the solution to the exam. And I want that to take 30 minutes, not bad. Okay, so that's the solution to the exam. So watch that during class on Tuesday. Remember, I will be back late on Wednesday. So we will have class on Thursday, no homework for Thursday. We can start off taking any questions about the exam you have on Thursday morning before we go. And I'm going to solve the homework assignment that was due right before midterms that a lot of folks struggled with. So we'll take a look at that. All right, I will see you when I see you.